Welcome to my class of science. Today we are looking at science paper 2, which is physics in this case. Okay, so there is a very good topic in physics called radioactivity, and that is what we are looking at today. So now, the first thing we have to understand what a radioactivity is. Very important. Okay, so radioactivity is the emission of radiation caused by a spontaneous disintegration of atomic nuclei. Okay, so that is radioactivity. So there are new terms here, scientific terms that you must understand there on radioactivity for you to understand it fully. So spontaneous simply means the natural happening. Okay, something that happens naturally is called spontaneous. The disintegration, that means the broken down of things. Okay, so that is disintegrate. So when we say caused by a spontaneous disintegration of atomic nuclei, meaning atoms, they undergo spontaneous disintegration. Okay, they are actually done. The breaking down of atoms or nuclear is done naturally without being forced. That is spontaneous. So that's what it means. So when you say radioactivities, that is what we are talking about. Okay, now from there we can look at the next point. Radioactivity is a random process. So when we say random process, I mean it is happening without considering. It's a process which is occurring without considering. That is a random process. Then there are three radiation emitted. We have to know this. On Earth, we have three radiation emitted. Then the first one is alpha, which is represented by this symbol, alpha particles. Then third one is beta, second one, fourth, beta, which is represented by this symbol, beta particle, and gamma rays. So we have three emitted radiation. Radioactivity elements are elements that emit radiation. So they are also radioactivity elements. So when we say radioactivity elements, we are talking about elements that emit radiation. Okay, as you may be aware, there are different types of elements on the periodic table. So among those, we have radioactivity elements, and these are elements that emit what? Radiation. So when we say emit, that is send off or give off, give off or send out. Okay, that is emission. That's what it means, that word emit. So when we say elements that emit radiation, meaning these are elements that gives off the what? Radiation. And we have talked about the type of radiation that are variable. We have alpha, beta, and gamma. Okay, then from there now we are going to look at the table which shows the characteristics of radiation. Okay, so the first column there, we have the second column, fourth and third, third and fourth. Okay, so we have this is what it is. Now it is trying to tell us alpha particle. So alpha particle, this is the column for alpha particle. We have two protons plus two neutrons. That is helium nucleus. Okay. Okay, that is alpha particle. We are giving an example of helium. Remember helium, this is an element which is also found on the periodic table. So it has got two protons and two neutrons. That is alpha particle. Then that is what it is. Then beta particle, that is now electrons. Okay, electron. Then X-ray, electromagnetic wave, which is a proton, electromagnetic wave. That is Y ray. Okay, then charge, alpha particle is positively charged. Okay, two positively charged. Then Beta particle is negatively charged, which is one negatively charged. Then Y ray or gamma ray, that one is neutral. Okay, neutral. Okay, zero. That is neutral. Something when it is neutral, it means it is just zero. It is neither positive nor negative. That's what it means. Then ionizing power, want to look at the ionizing power for alpha particle. That one is very strong, ionizing power. Alpha particle is very strong because that one is positively charged, and therefore it should be very strong. So when we say ionize, which power are we talking about ionizing power? So we are talking about the power because the word itself, ionize, simply means to add or remove electrons to an element, okay, or a molecule for it to be what? To be charged. Okay, you are going to add electrons or remove electrons, and as you are doing that, it means that particular element is going to have a charge. And once the element or molecule or compound gains charge, that means that particular element, compound, or molecule will actually become an ion. That's what it means. So ionizing power. So we are talking about the ionizing power to make something to be chargeable, to change it from the normal way to a charge. So when you look at alpha particle, that one is very strong. Then beta particle, that one is weak. Why? Because it's negatively charged. Then when you look at gamma ray or Y ray, that one is very weak. Okay, there are no charge there. There is only neutral. Okay, so therefore, the ionizing power is going to be very weak. So these are some of the characteristics of the three radiation that I've outlined on the first place there. Then we continue, the table continues. Here, alpha particle, we are now looking at penetrating power. Penetrating power. So when we say penetrating, this is radiation. So to penetrate is to pierce. Okay, for example, even in my body myself, your body. So now the power to penetrate, because radiation at times they penetrate, they can penetrate even the opaque material. So now we were looking at now penetrating in power. So for penetrating power, we have the alpha particle very weak. Alpha particle is weak, then beta particle is weak. Then Y ray, which is gamma ray, that one is very strong when it comes to penetrate. It has no limits. It penetrates anywhere, even in the bone, it goes there. That's why when we talk of scans, that's the type of radiation which they use because it has got no boundaries. Okay, it's very powerful. Then absorbed by alpha particle is being absorbed by a sheet of paper. Then beta particle is absorbed by 5 millimeters aluminium. Then Y ray is absorbed by 5 centimeters lead. Lead, that is an element. Aluminium is an element. You know, there are those things. Then range in hair. What about the range in hair? Okay, the coverage, the length. This one, few millimeters, that is the alpha particle. Then beta particle, few in centimeters. This one millimeter, this one centimeter. Then the Y ray is infinite, meaning infinite, that is everywhere. It has got no limit for that one when it comes to range in hair. Then diffraction in electric field. This one, alpha particle, diffract in electrical field. That's why they are saying yes. Beta particle also diffract, yes. Then Y ray does not diffract. When we say diffract, redirect, okay, in electrical field. Then that goes to magnetic field also. This one diffract in magnetic field, which is an alpha particle. Then beta particle also diffract in magnetic field. Whereas Y ray or gamma ray does not diffract in magnetic field. There is nothing like redirecting because of the magnetic field. No, it just PS. It just go. Doesn't work like that for Y ray. Okay, so this is the introduction of radioactivity and the few points under it. I really appreciate for your attention, and I would encourage you to actually uh, continue following me by subscribing to my YouTube channel, as well as follow me on my Facebook page, Mr. A Plus, and on TikTok. Okay. Thank you so very much for now.